Hello everyone, welcome to KPSS UPSC Universe. I'm Sowjanya, Faculty of Current Affairs. In this video, we're going to discuss one important article from the Hindu today. So the article that we're going to discuss today is India's third lunar odyssey begins the perfect launch. So we're going to discuss about Chandrayaan 3. So these are the things that we're going to discuss in this video. First of all, why is it in news? And then we'll look at the syllabus relevance of this topic, both from the point of view of prelims and then mains. We'll discuss a previous year question from prelims and then an expected prelims question, previous year question of mains, and then a practice question for mains. After this, we'll discuss have a detailed explanation of the important concepts, like we'll discuss about Chandrayaan 3, the objective of the mission, lander and rover payloads, and then we'll discuss about the overcoming the past challenges of Chandrayaan 2, and then we'll discuss about the recent update that we have today in news, and then we'll discuss about what is a orbit, and then we'll discuss what is a parking orbit, which is in news today. So these are the things that we're going to discuss today. So first of all, why is it in news? As we know, India's third moon mission, that is Chandrayaan 3, it was successfully launched on board a launch vehicle Mark 3. So this is one first point that you have to remember. It is LVM-3 rocket, and this is from the Satish Dhawan Space Center in Sriharikota on July 14, that is yesterday. So Chandrayaan 3 was successfully launched yesterday. So this is why it is in news, and you have to remember the launch vehicle Mark 3, that is LVM-3. So coming to the syllabus relevance of UPSC, from the point of view of prelims, it comes under science and technology, and from the point of mains, it comes under general studies 3. So it comes under awareness in the field of space. So here the most important concept in this article is definitely Chandrayaan 3. So coming to our previous year question, consider the following statements. The Mangalyaan launched by ISRO, it is also called as Mars Orbiter Mission MOM, and it made India second country to have a spacecraft orbit the Mars after USA, made India the only country to be successful in making its spacecraft orbit the Mars in its very first attempt. So here you have to identify the correct statement. This question was given in 2016. So earlier we had a question on Mangalyaan, so definitely we can expect a question on Chandrayaan also. So this is how it works. So you have to definitely go through the previous year questions so that you'll get to know the pattern of how questions can be framed on a particular topic. So here coming to this question, the correct answer is 1 and 3. So first statement is correct because Mangalyaan, it is also known as Mars Orbiter Mission, and it made India the only country to be successful in making its spacecraft orbit the Mars in its very first attempt. And then coming to today's prelims practice question, consider the following statements related to Chandrayaan 3. So the statements are, Chandrayaan 3 will primarily target Moon's northern pole because it has more shadowed space than the southern pole. So as we know, Moon also has north pole and south pole. So you have to remember which pole is the target of Chandrayaan 3. So far, only 3 countries have successfully soft landed on the moon. So here you have to identify the correct statements. So this is how the pattern of UPSC is in the recent exams, that if you see, so only 1, only 2, both statements and none. So here the correct answer is A, only one statement is correct. So which is that one statement? It is B. First statement is incorrect. So we'll look at it why it is incorrect. So far only 3 countries, that is USA, Russia and China. These are the 3 countries which have soft landed on the moon. So do remember, it's US, Russia and China. These 3 are the countries which have soft landed on the moon so far. So that is the reason why our second statement is correct. And Chandrayaan 3, it will primarily target the moon's southern pole. So here the question is, it says it is northern pole, so that is the reason why it is the wrong statement. So it targets southern pole of moon. Why? Because it has more shadowed space than the northern pole, and these regions of the lunar surface, it may have a constant supply of water according to the scientists. So if you look at the southern pole and the northern pole, compared to the northern pole, southern pole has a more shadowed region, and scientists are also anticipating that there is more supply of constant supply of water in the southern pole, and additionally the craters found at the southern pole, they are of great interest to the scientists. So they think that the cryptic fossil records of the early planetary system, they may be present in this coal traps. So they feel that, scientists feel that in the southern pole there are some ice traps wherein there is a constant supply of water, and also because it's a shadowed region when compared to the northern pole, it's a shadowed region, so there might be some fossil records of early planetary system, early solar system, about the origins of the moon, etc. So this is why the scientists are very interested about the southern pole of moon, and the target of our Chandrayaan 3 is also southern pole of moon. So do remember this. So coming to the main PYQ exercise, in the year 2017 we had a question. India has achieved remarkable successes in unmanned space missions, including the Chandrayaan and Mars orbiter mission, but has not ventured into manned space mission both in terms of technology and logistics. Explain critically. So this was the question. So here you have to identify that this question was asked back in 2017. So it is not fully relevant to today's times, because after this Chandrayaan, we have Chandrayaan 2, now we have successfully launched Chandrayaan 3, and we are also planning for this Gaganyaan, which is a manned space mission. So this is also in news today. We also have an article on Gaganyaan also today, and comparison of Chandrayaan and Gaganyaan, that is, Chandrayaan has helped Gaganyaan mission. So this would be also discussed. And at that time we had this Chandrayaan and Mars orbiter mission. So back in 2017 this question was asked. So coming to today's mains practice question, why do you think ISRO has targeted the south pole of moon in its Chandrayaan 3 mission? Also discuss the associated challenges and what is its impact on Gaganyaan mission. So we'll have a brief discussion on how to write your model answer for this question. Before that, let's have a look at the detailed explanation of today's important concept, that is Chandrayaan 3, and then we'll get back to this topic of today's mains practice question. So coming to about the basics of Chandrayaan 3, it is India's third moon mission, Chandrayaan 3, and it was successfully launched yesterday with LVM-3 rocket. So this was launched on board our LVM-3 rocket, launch vehicle Mark 3. So this was formerly GSLV Mark 3. So this was launched from Satish Dhawan Space Center in Sriharikota. And Chandrayaan 3, as we know, it's India's third moon mission. It follows Chandrayaan 2 to demonstrate end-to-end capability in safe landing and roving on the lunar surface. So earlier we have seen that soft landing on the moon, this was done only by 3 countries so far, and now India is aiming to be the 4th such country to make a soft landing on the moon, right? So the major objective is to have a soft and smooth and safe landing on the moon, and also roving on the lunar surface, and the target is southern pole of moon. So coming to the objective of the mission, Chandrayaan mission, it is to explore the far side of the moon, and the primary objective will be to demonstrate the soft landing capability on the moon. So as we have already discussed, soft landing of the moon on the moon is one of the major objectives of Chandrayaan 3, and it will primarily target moon's southern pole because it has more shadowed space than the northern pole. And as we have seen, these regions of the lunar surface, they may have a constant supply of water according to the scientists, and they are anticipating that there are some ice traps over there which could have some mystery regarding our formation of moon, and also about our planetary system, our solar system, etc. So this is of a great interest to our scientists because there are some craters that are found at the southern pole, and also they feel that there are some fossil records of early planetary system and the formation of our early solar system, and also regarding the formation of moon, because they say that moon formed from the debris of the collision of a Mars sized object with Earth. So if we can reach the southern pole of moon, we can definitely unravel some mysteries regarding the formation of our solar system and the formation of moon. So the aim of this mission is to develop and demonstrate new technologies required for the interplanetary missions. So this is the objective of the mission. Coming to the modules that we have, it consists of an indigenous lander module, then we have a propulsion module and a rover. So these are the three basic terms that you have to remember: lander module, then we have propulsion module, and then we have a rover. So these are the three terms that you have to remember, and the objective is of developing and demonstrating new technologies that are required for interplanetary missions. Interplanetary missions means from one planet to another planet. For example, from Earth to Moon, from Earth to any other planet. So in order to plan such interplanetary missions, this Chandrayaan 3, it would display like whatever new technologies are required for a interplanetary mission. So what do we have in a propulsion module? In this, it will have a lander rover configuration to 100 kilometers lunar orbit. And once the Vikram lander module makes it safely to the moon, then it will deploy Pragyan. So this will carry the chemical analysis of lunar surface during the course of its mobility. So first of all, on the name of Vikram Sarabhai, the lander was named as Vikram. So this lander module, first of all, it has to make it safely to the moon. After it reaches the moon safely, once it lands safely, what will happen? It will slowly deploy Pragyan. So these names are also important. Try to remember this. So it will deploy Pragyan. So what will Pragyan do on the surface of the moon? It will do a chemical analysis of the surface. So during the course of its mobility, so on the path of its movement, whatever path it is moving on the moon, in that path it will do a chemical analysis of the lunar surface, that is the surface of the moon. So chemical analysis will be done by Pragyan. So Vikram is the lander. So once it lands safely, it will deploy the rover. It will deploy the Pragyan rover. So Pragyan, what it will do is it will do the chemical analysis of the lunar surface. So lander, rover and propulsion mode, they will have payloads for performing experiments designed to give scientists new insights into the characteristics of Earth's lone natural satellite. So as we know, the only natural satellite our Earth has is Moon. So whatever our scientists are trying to find out on the moon, so whatever new insights they are trying to get from the moon, that will be done by these lander, rover and propulsion module. So they will have some payloads. So with that payloads, they will perform some experiments on the surface of the moon, so that our scientists will get new insights of different aspects of the moon. So coming to the payloads of the lander, so the lander will have 4 payloads. So one is radio anatomy of moon-bound hypersensitive ionosphere and atmosphere, and then we have Chandra's surface thermophysical experiment, and then we have ILSA, that is instrument for lunar seismic activity, and then we have laser retroreflector array. So these are the 4 payloads that we have on the lander. So we'll also discuss about this path of our Chandrayaan 3 and we'll discuss about the orbit also later. So for now, remember these. Regarding our launch vehicle, as we know, it is LVM Mark 3, launch vehicle Mark 3 or LVM 3. So this is what is the path followed by our Chandrayaan 3. So before reaching this moon, what will happen is Chandrayaan 3, it will follow the same trajectory as its predecessor. That means whatever path is followed by Chandrayaan 2, as we know, we already have Chandrayaan 1 and Chandrayaan 2. So whatever path is followed by Chandrayaan 2, the same path will be followed by Chandrayaan 3 also. So the propulsion module, it will orbit the Earth several times before slingshotting towards the moon. Right. So what our propulsion module will do, for example, this is our Earth. So here you can see that it will first orbit around the Earth several times, and then it will slingshot to the moon. So for example, as kids, we would have played, we would have definitely tied a rope to a stone. We would first rotate it fast and then we'll throw it, right? So in a similar way, here also what happens is this propulsion module, it will first orbit the earth some several times, and then suddenly it will slingshot to the moon, right? So this is what is have the movement of the propulsion module would be. So hope you are clear with the movement of the propulsion module. So once it is within the moon's gravitational pull, then the module, it will lower itself to a 100 by 100 kilometers circular orbit. So once it slingshots to the moon, what will happen? It will enter the gravitational pull of moon. So once it enters the gravitational pull of the moon, then what will happen is it will lower itself to a 100 by 100 kilometers circular orbit. So this is how will be the movement of our propulsion module. So subsequently the lander will detach and it will descend to the surface. So once so we'll get back again and I'll have a slight repetition of how it moves. So the propulsion module, it will orbit the earth several times like this, and then it will be slingshot to the moon, and once it reaches into the gravitational pull of the moon, then it will lower itself and it will come into a circular orbit, and then slowly our lander, it will reach the surface. And as we have seen, once our Vikram lander, it makes a safe landing on the moon, it will deploy Pragyan, and Pragyan, it will move on the surface of the moon, and while moving it will do the chemical analysis, and whatever payloads that our scientists have sent, with these payloads some experiments would be performed, so that we'll get new insights on the regarding the surface of the moon. So this is what is basically what happens on the with the Chandrayaan 3. So coming to our rover payloads, the six-wheeled rover, it will have two payloads. One is APXS and the other one is LIBS. So one is alpha particle X-ray spectrometer and the other one is laser induced breakdown spectroscope. So in addition to these two, there will be one payload on the propulsion module also. So that would be our spectropolarimetry of habitable planet Earth. And according to ISRO, lander has the capacity to soft land at a specific lunar site. For example, this is the entire moon. We have a north pole and a south pole, and within the south pole also we have a particular site that okay, our Chandrayaan 3 has to land on this particular site. So our scientists say that according to ISRO, lander has the capability to soft land at a particular site. If we wanted to land at a particular site, it has the capability of soft landing at that particular site itself, and then it will deploy the rover, and rover, as we have discussed, it will carry out chemical analysis of the lunar surface. Both of them have scientific payloads, as we have discussed, and we have also discussed about the circular polar orbit, and after its launch, orbital rising will take place, and ISRO has added more fuel to the lander. And Chandrayaan 3, as we have discussed, it will go in the same path as Chandrayaan 2, and it will be landing on the same site of Chandrayaan 2. So this is one more point that you have to remember. So coming to our past challenges, when a failed attempt at a soft landing resulted in the loss of lander rover combo and the payloads, Chandrayaan 2 program suffered some setbacks. So back then when we had this launch of Chandrayaan 2, at that time there was a attempt to soft landing, like whatever we are attempting now for soft landing. At that time also our major objective was to have a soft landing on the moon, but unexpectedly we had a failed attempt wherein we have lost our rover and lander combo, and also we have lost our payloads. So there were some setbacks at that time. So unruffled by this failure of this first mission, ISRO revealed its intentions for Chandrayaan 3, which aims for a successful lunar landing. And coming to the recent update, like what has happened yesterday. So this is India's second attempt at soft landing robotic instruments on the lunar surface after the previous attempt, that is Chandrayaan 2, it failed in 2019. So do remember Chandrayaan 2, we had a failed attempt back in 2019, and now today we have successfully launched Chandrayaan 3 in 2023. So without having a setback after a failed attempt in 2019, we have again successfully tried for this soft landing on the moon in 2023. So thus far only 3 countries, that is USA, Russia and China, they have successfully soft landed on the moon. So if successful, this mission will solidify India's position as the 4th country to achieve a controlled soft landing on the moon. Right, so after these countries, India, it is aiming to become the 4th country to have a soft landing on the moon. So the lunar lander Vikram, it is perched atop the mighty Mark III heavy lift launch vehicle, as we have discussed, that is our LVM-3. So this is affectionately dubbed as Bahubali rocket. And around 16 minutes after this LVM-3 lifted off, spacecraft separated from the rocket. And once it is on the lunar surface, Vikram will operate for 1 lunar day. So this is one more important point from examination point of view. So it will operate for 1 lunar day. So do remember, it is not our 1 day on Earth, it is 1 lunar day. So it means 14 Earth days. So if you get a statement based question like it is 1 Earth day, it would be a wrong statement because it is a 1 lunar day and it is equivalent to 14 Earth days. So for us, if 14 days are passed, on moon it will be only 1 lunar day. So do remember this particular conversion. And coming to orbit, so we have been listening to this particular term called as orbit. So what is basically an orbit? An orbit is a curved path that an object in space takes around another object due to gravity. So it can be a star, a planet, moon, asteroid or spacecraft. So for example, if we have Earth, the moon, it is revolving around the Earth, right? So our only natural satellite moon, it is revolving around our Earth. So whatever path, this curved path is taken by our moon. So this is what is an orbit. So due to the gravity between two bodies, if it is rotating, revolving around one other body due to the gravity, so the path that is taken, that is what is our orbit. So objects of similar mass orbit each other with neither object at the center, while small objects orbit around larger objects. For example, if we have two objects of same size, then what will happen? Both will have an orbit, but no object will be at the center. But if one is small and other one is large, for example, Earth and Moon combination. So Earth is large and Moon is small. So what will happen? One object will be at the center. That is, larger object will be at the center, and the smaller one, it will revolve around the larger object. So that will be that will have the orbit takes place. So coming to parking orbit, so this is one important term that is in news today. So this is also important. So when there are different kinds of terms that are used in news, you have to be careful with that because questions can be definitely asked in MCQs based on those new terms or less used terms in the news. So coming to parking orbit. So what is a parking orbit? It is a temporary orbit that is used during the launch of a spacecraft. For example, so you can easily remember this way. So if you go for shopping, you will park your vehicle. So that will be just for a temporary period. You will not park it for a permanent period, right? So you will just park it for a temporary period. So similarly, our satellite or our spacecraft, it will also be there for a temporary period. So parking orbit is basically a temporary orbit that is used during the launch of a spacecraft. So launch vehicle, it boosts into the parking orbit, then it coasts for a while, and then it fires again into the final desired trajectory. That means our launch vehicle, it will first boost into the parking orbit. So it will coast for a while, then it will fire into the original final desired trajectory or the path. So trajectory is nothing but the path. So whatever is the desired final path we have, first of all, our spacecraft, it will fire into, it will boost into our parking orbit, it will coast for a while, and then it will fire into the final desired trajectory or path that we have. So an alternative to parking orbit. So one is parking orbit. So we have an alternative to this, that is direct injection. So by the term itself, you can understand a direct injection. So where what happens, the rocket, it will fire continuously until its fuel is exhausted, ending with the payload on the final trajectory. So it will directly go into the final trajectory. So whatever is the final path is present, so under this direct injection, the spacecraft will directly go into the final desired trajectory. But in case of a parking orbit, so it will first boost into the parking orbit, goes there for a while, and then it will fire into the final orbit, right? So this is what you have to remember regarding this parking orbit, which is one important term. So this technology was first used by Soviet Venera 1 mission to Venus. So this is also an important point. And Chandrayaan 3, it entered an elliptic parking orbit. So this is why we have this term in use, because Chandrayaan 3, it entered an elliptic parking orbit, that is EPO. So EPO's closest approach to Earth, it was around 170 kilometers, and the farthest would be 36,500 kilometers. So these are basically the details that you have to remember regarding Chandrayaan. So we have one more thing left, that is our mains practice question. So why do you think ISRO has targeted the south pole of the moon in its Chandrayaan 3 mission? So first reason, as we know, it's a shadowed region compared to the north pole. The south pole of moon, it is more shadowed region. And also they say that there are water resources available here. So at the southern pole of moon, there are some ice traps wherein they have continuous supply of water. This is what is anticipated by our scientists. And also we have some evidences of formation of moon, formation of our planetary system, our solar system, because moon is considered to be formed after, from the debris that is formed after the collision of a Mars-sized object with Earth. So they feel that there could be some evidences of this formation of our planetary system. So these are various reasons why our southern pole of the moon is targeted by Chandrayaan 3. So we have targeted it, okay, but do we have any challenges? Yes, we do have some challenges of launching our spacecraft on the southern pole of the moon, because generally near the moon's equator, we'll generally take this equatorial region. They are landed on equatorial region, that is on the moon's equator, some degrees north or some degrees south. Only here mostly they are landed, but we have chosen this southern pole, right? So what will happen here in we do not have much information about this because it's a shadowed region also. And also if you consider the sunlight factor, sunlight is more at the equatorial region of the moon and also at the north pole. But if you look at the south pole of the moon, the sunlight is not present, so it's a considerably darker region. So it is a bit more challenging compared to launching it at the equatorial region or the north pole. Launching it at the southern pole is a bit challenging thing. So what is its impact on Gaganyaan mission? So coming to its impact on the Gaganyaan mission, if you look at, so Gaganyaan mission, it is basically a manned mission. So before we are sending human beings into space, what we'll do is we'll have a trial of unmanned space missions. Only after these are successful, then we'll have a manned space mission. So what is its relation with Chandrayaan 3? In Chandrayaan 3, whatever new technologies that we are using, that technologies, if they are demonstrated to be successful, then these would be definitely helpful for Gaganyaan also. We can be confident enough of Gaganyaan also if these new technologies that we are demonstrating here become successful in case of Chandrayaan 3, right? So why are we having this Gaganyaan mission? Because if we are having a particular rocket, a manned rocket, in the way, on the way, if there is unfortunately some mishap has happened and there is some accident or there is a blast of the rocket, so what would happen to the people or the human beings inside that? So how is our capability to save those human beings? So for these, so to demonstrate this, our Gaganyaan mission was launched so that we can save our humans in case of such emergency situations, wherein in the on the way in the rockets, if there is some mishap that has happened, so have to save these people. So this would be demonstrated by our Gaganyaan mission. So this is about our Chandrayaan 3 mission that is in news today. So hope you have liked this video. Thank you.